So we're going to finish up section 6.5, and the first thing we're going to look at is what it means to solve a triangle. Okay. When they ask you to solve a triangle, that means you need to figure out all the sides and all the angles. But we know we're working with a right triangle, so we already know one angle in every problem. Okay, that's a 90. But in addition to knowing that you have a 90, I need to give you two other pieces of information to make the problem solvable. There's two cases. So in addition to the 90, I can either give you another angle in the triangle and a side, and that's enough information for you to figure out everything else. Or I can give you two sides. Depending on what I give you, that is going to change how you need to solve the problem. Okay. So we'll go through an example of each type. So a couple things that we can use. Pythagorean theorem is something that you are allowed to use to do this. And keep in mind that all the angles in a triangle have to add up to 180. One thing we generally want to avoid, though, is we're going to be missing three things in every problem. You do not want to use something that you calculated by hand to then calculate something else. Why do you think using something that you found to then find something else is not a good idea? Yeah?
There's room for error.
Okay, so your answer might have error in it because you rounded. So if you use a rounded number to find something else, and then you round that answer again, now you're rounding too many times, right? What might be another reason besides you have an answer that's rounded? Yeah?
Is it because you're meant to be able to find every piece of missing information with the information that they give you?
Correct. You can find every piece of missing information with just what they give you, and that's how we're going to do it. But what's another reason why you wouldn't want to use one of your answers? Besides, it could be a rounding situation, yeah?
If you by chance got it wrong.
Yeah, it could just be completely wrong. So if your answer is wrong and you use it to find something else, then that answer is going to be wrong. So you're always going to use what was given to find what you need to find. Okay. All right, so how do you do it? Well, every problem is going to involve picking a trig function. The only three trig functions we're going to use are sine, cosine, and tangent. The reason why is because on your calculator, those are the ones you have buttons for: sine, cosine, and tangent. We could use secant, and cosecant, and cotangent. It'd just be a little bit harder, be some extra steps. Okay, so we're always going to pick one of those three. And the way that you're going to figure out which trig function to pick is you're going to draw a diagram, you're going to label it, and you're going to look at what is it that they gave me. What's the position of that side? Did they give me opposite, adjacent, or hypotenuse? And then what side is it that I need to find? Is it opposite, adjacent, or hypotenuse? And depending on which two sides are involved, the one you know and the one you want to know, you're going to figure out the trig function. So if they give you the opposite and you're trying to solve for hypotenuse, opposite and hypotenuse is sine. If they give you the adjacent and you're trying to find the opposite and adjacent is tangent. So we just have to figure out which two sides are going to be involved. All right, so let's try this. It says one angle of a right triangle is 37 degrees. The hypotenuse is 8. And solve implies find all the angles and sides you don't know. All right. So with that information, what do you think the first thing that we should do is? Yep.
We should find the last angle because we have two of the angles already.
Okay, so we can easily find that last angle. But before we even do any math, what should I do with that? Yeah?
Draw it.
Yeah, let's draw it out. So you're going to make a right triangle. It doesn't matter how the triangle is oriented. You can draw your triangle a different way if you want. It just matters where we put our labels. All right, so hypotenuse is 8. It doesn't matter where you put the 37. Okay, I'm just going to put it right there. But I would like to label the things that I don't know so I have a way to reference them. How could I label the height? What letter could that be? Kim? Yeah, we can label that A. That works. How about the bottom side? What letter could we use? Yeah. We could use B. Okay, we can label that side C, but we know it's A, so we don't really need to call it C. What would be the name of the angle across from B? What would we name that? Yep.
That would be beta.
That's beta, and this angle would be alpha. All right. So now, once we draw the diagram, first thing I do is off to the side. I'm going to make a table, and it's going to have all my information in it. We don't need the sixth piece of information because we always know it's a right angle. So when it's not a right angle, we're going to have to figure that one out too. But that's not in this section. All right, so let's label what we know. A, I'm going to put a box around it because I need to find it. B, put a box around it. C, I know is 8. Okay, alpha is 37. And beta, I don't know. So when I'm done, I need to fill in those 3 boxes. All right, what could I find first? Pretty easily. What piece of information? Yep.
Beta?
Yeah, we can get beta pretty easily. And how would you get that?
I would just subtract 37 from 90.
Yeah, we know that alpha and beta are complementary, so just subtract 37 from 90, and you're going to get 50. Not that. You're going to get 53. So 90 minus 37 gives you 53. Okay. Any questions on how we got beta? All right. Now we need to get A and B. To get A and B, we have to pick an angle to use as our reference point. All right. Should I use alpha or should I use beta? Which angle should be it's kind of like my point of reference, yeah? Yeah, we definitely want to use alpha because we know it's right. So we're going to use this angle. And now we need 2 other pieces of information. Okay, whenever you're setting up a trig equation, you need 3 things in it. Okay, we're going to use that. What's something else do you think I'm going to use in my equation? Yeah?
Hypotenuse?
Yep, I definitely want to use the 8 because that was given. And now it's just a matter of which one you want to find first, okay, A or B. It doesn't matter. Yeah?
It would be, you could either do sine or cosine of alpha.
All right, so do you want to solve for A or B first?
I don't really care.
You don't really care.
It doesn't matter.
It doesn't matter. All right. Do you have a favorite letter? No. Okay. All right, let's do A. So let's find A.
Just cause.
Just because. All right, so if we want to find A, I'm going to circle that one. Let's label the positions of these sides. By position, I mean opposite, adjacent, or hypotenuse. What position is side A? And everything is from the perspective of 37. Yeah, that is opposite. So we are trying to figure out the opposite side. And what's the position of the side that's 8? Yeah. No, B is adjacent. Because the 8 is across from what? No, 8. I mean, what angle is 8 across from? No, B is across from beta. The 8 is across from the 90. Yeah. So what side is the 8? Hypotenuse. Yeah. So we know the hypotenuse. We want to find the opposite. What trig function, sine, cosine, or tangent, involves opposite and hypotenuse? Yep.
Sine.
Sine. So all of them are pretty much going to look like this. A trig function, an angle, and a fraction on the other side. It might not always be sine. So the sine of, you fill in your angle, 37 degrees, equals, and the definition of sine is opposite over hypotenuse. So what am I going to fill in for that fraction on the right side? Yeah. A over 8. And now, solve for A. Okay, so multiply each side by 8. And that's your answer. Okay, we need to type that in and round it off. Okay, and we're going to round to 3 decimal places. Before I type that in, what do you think I need to check on my calculator? Yeah? Right. I need to make sure I'm in the right mode, and all the angles in this section will be degrees. So you should be able to put it in degrees. I don't think there's any in radians. And that's how you type it in. Okay. So A is 4.815. Okay. All right. So now we have 2 out of 3 sides in the triangle. What theorem can you use to find the third side if you know 2 of the sides? Yeah?
Pythagorean theorem.
You could use the Pythagorean theorem, but why am I going to probably say that's not how I want to do it? Yeah?
Because you don't have the odd number that's. A has decimals.
Okay, A has decimals. It's because I found it. All right? I don't want to use something that I found to find B. Okay? So let's find B the same way we found A. Okay. So now we're going to be looking at everything that's circled in green. What we didn't, I think we said it, but we didn't label it. What position is side B? That's adjacent. Yeah. So now we're trying to find the adjacent, and we're using the hypotenuse because it was given. Which trig function has adjacent and hypotenuse? Yep. Cosine. Okay, so it's the cosine of your angle equals adjacent over hypotenuse. B divided by 8 times each side by 8. And there you go. That's how you find B. So it's 8 cosine 37. So 6.389. Now, if you want, and you have time on the test, you can check if you square A and you square B, and you add them up and take the square root, you should get about 8. It'll probably come out to like 7.99 or 8.001 because we rounded. Right? But if you want to check it with Pythagorean theorem, go ahead.
Calculator plus strength to 8.
Yeah. What's that?
Calculator plus strength to 8.
Oh, okay. I just, yeah, with the rounding. Just. Any questions on that one? So that's an example of the first case. I gave you an angle and I gave you a side. You could try another one with an angle. People want to see another one with an angle. Yeah, do one more with an angle and a side. Okay. So make your diagram. Where can we put the 12.3? There's only one place you really don't want to put it. So where could I put it? Yeah?
Any of the acute angles?
Yeah.
No, just not hypotenuse.
Just don't make it the hypotenuse. Yeah. So just make it the shorter, one of the shorter legs, or one of the shorter sides. So 12.3. And now if I put that there, where does the 20 have to go? There's no choice now. Yep.
Opposite of it.
Opposite. So that's my 20. So we're going to call that A, B, C. We'll call that alpha. And that's beta. So we get our diagram with everything labeled. Again, off to the side. Listen, make your chart, make your table. Okay, I'm not even going to put the right angle because we don't need it. A we know. B we do not. C we don't know. Alpha we know. And beta was not given. All right. So I would start with the angle. What is beta going to be? Yep. Beta is going to be 70. Okay. Now that you have beta, forget about it. Don't use it for anything else. I'm going to circle the two things I was given. That and that. Okay. Which one do we want to try to find first? B or C? Any preference? I need a preference. Yeah.
Let's just go with B.
Let's go with B. All right. So I'm going to find B. Let's circle that one. What is the position of side A relative to the 20? It's the opposite. How about the position of side B? That's the adjacent. And the position of side C would be? Yeah,
Hypotenuse.
the hypotenuse. Okay. So which trig function am I going to need if I want to solve for B and I know A? Which trig function? Yep.
Tangent.
Tangent. Yep. So the tangent of my angle equals opposite over adjacent. 12.3 over B. Let's see. Now, I'm going to show you what ends up happening here when you have a letter in the bottom. I'll kind of do it out this time, but then from now on, we're going to use a shortcut. If you multiply both sides by B, the B's cancel, and now you have this. And then how would you get tangent of 20 on the other side? Yep.
Divide both sides by tan of 20, so it's 12.3 over tan 20 equals B.
Yeah. So look at what you started with, and then look at what you ended with. Basically, these two things just switch places. Okay. So that's a shortcut we can use from now on. So that's B, 12.3 divided by tangent 20. Tangent 20. And that's the reason I wanted to do this problem, because the last problem never ended up with a variable in the bottom. The variable was always in the top. But that's what happens when it's in the bottom. So that's 33.7. We're going to round that up to 794. 33,794. Right. And I'm not going to go through C, but which trig function would you use? If you were trying to find this, using that, and that. James, which trig function would that be?
For
To find C.
Find C. Okay. So my brain is failing me. Wouldn't that be? Oh no, you can't do. My brain is failing me right now.
Oh,
Sine.
you would use sine. You know the opposite. You want the hypotenuse. The only trig function that has those two out of sine, cosine, and tangent is sine. Okay. Another thing you can check when you're done the problem, the smallest side should always go with the smallest angle. The biggest side has to be across from the biggest angle, and then the medium side is with the medium angle. That's just kind of a quick thing you can check to make sure it looks reasonable. The other thing you can check is in a triangle, any two sides added together have to be bigger than the third side, always. So 4 and 6 is bigger than 8, 6 and 8 is bigger than 4, and 4 plus 8 is bigger than 6. So if you ever end up with two sides added up and it's not bigger than the third, then something is definitely wrong. Like you can't have sides of like 1, 1, and 10. You couldn't make a triangle with that. All right, so those are just a couple things when I'm done. I look at it real quick to make sure I didn't make a obvious mistake. All right, so now let's look at the case where we are given two sides. So it says we're going to have the hypotenuse and one of the shorter legs. It doesn't matter which leg you make it. Just make the leg the right number. You kind of need to know between those two numbers which one is the hypotenuse, even though I didn't say it. Which number there is the hypotenuse?
12.7.
It has to be the 12.7. How come?
Because the hypotenuse is the largest side.
Right, the
And it says
hypotenuse
it
is the
gives-
largest side.
and it says it gives you the hypotenuse.
Yes, it also says it gives you a leg. So it says it gives you a hypotenuse and a leg. Okay, but you should know which, make sure you know which one is which. Okay, so 12.7. And that's 6.1. All right, so labeled our diagram. Let's call that A, B, C, alpha, beta. Okay, so the way we solve this one, it's going to be a little bit different. A, we don't know. B, we do. And C, we do. That we don't. And that we don't. All right. What could I start with this time? Yeah?
You could either do alpha equals cosine of alpha equals 6.1 over 12.7.
Okay, so we can set it up to solve for the angle. I'm going to come back to solving for the angle, but yes, we could definitely use cosine to solve for alpha. Yeah. How about A? Yeah.
Uses the Pythagorean theorem.
Okay, how come, last time I wasn't okay with that, but how come this time you think I'm going to be okay with using it? Yeah.
Because both the sides were given to us.
Yeah.
We know that, right?
Both the sides are given, so everything you're plugging into the Pythagorean theorem is exact, and we know it's right. So a squared plus b squared equals c squared. And ideally, I'd like to not round any of that. I don't even want to do any of that out until I get a by itself. So what's the first thing I could do here to get a by itself? Yep.
Subtract 6.1 squared from both sides.
Yep. So let's just subtract 6.1 squared. So that gives me a squared. That's gone. Equals 12.7 squared minus 6.1 squared. And then what's the last thing I would do to get a by itself?
Square root.
Take the square root. That's ideally how I'd like you to solve it. That way you're not doing any rounding until you're at the very last step. And we're only going to round one time. Okay, let's put all that in. Square root of 12.7 squared minus 6.1 squared. So that gives me a length of 11.139. Okay, so that's A. All right, now let's do alpha, just because that's what we mentioned a second ago. So we're going to use alpha as our perspective, because that's the angle we want to find. And we're going to use the two pieces of information that we're given. What position is side B relative to alpha? Yep, that's adjacent. And what position is side C? James? That's the hypotenuse. Which trig function involves hypotenuse and adjacent? Yep. Cosine. So let's set all that up. So cosine of, always fill in your angle. The angle this time is alpha, equals adjacent over hypotenuse, 6.1 over 12.7. What is different about that equation than the last 2 or 3 trig equations we set up? Yeah?
We don't have, actually, we have 2 side lengths.
Okay, we have 2 side lengths. So where's the variable?
The variable is the angle.
Right, the variable is the angle. We haven't had one like that. This is inside of the cosine function. It's kind of like having something like, log of x equals 13.2. That x is inside of the log function. So you have to do something to cancel out that function. Right? If you had a variable inside the square root function, what would you do to cancel out the square root function? Yep.
You square both sides.
You would square it. Okay? You have to use another function that cancels out the one you have. So is that how we did it? 6.1 over 12.7? Yeah. I called it a different angle. I'm going to rename it so it matches ours. So that's what we have. And to cancel out that cosine, we have to use what's called inverse trig. Inverse trig is kind of like comparing squaring and square rooting. They cancel each other out. So there are 3 inverse trig functions we're going to look at. Inverse sine, inverse cosine, and inverse tangent. Having a -1 up a little bit higher has nothing to do with raising it to the -1 power. Putting a -1 a little higher on a trig function is a special symbol that means inverse trig. If you really did want to raise a trig function to a -1 power, you would have to do it like this. That's how you represent raising a trig function to a negative power.
And that would be secant, or cosecant.
Yeah. And then when you raise it to a -1 power, it actually flips it and it makes it a cosecant. But this is not a -1 power. It's confusing because it's written like an exponent, but it's not. There's also a different way you can write inverse trig, and you might see that either in our book or on a test. It means exactly the same thing. So if you see the word arcsine, and you don't like it because it doesn't look like what you're used to seeing, and it doesn't match the button on the calculator, you can just change it to inverse sine. It's just a different name for it. On the calculator, the way you get to an inverse trig function is you press second, and then you press either sine, cosine, or tangent. So you have to press second first. And when we use an inverse trig function, The correct word to explain how we're going to use it is take. We're going to take the inverse sine of whatever our problem is. Just like if you had this, let's say, and I asked you to solve that. The way you would explain that is you'd say you take the square root on both sides. You don't say you're going to multiply both sides by the square root. That doesn't make sense. Multiplying is reserved for numbers and letters. You cannot multiply by a word on both sides, or a function. Right? So I would say take the square root of what's on the left, take the square root of what's on the right. Right? That's the verb you want to use, take. So now, let's try that here. We are at that step. We need to get rid of cosine. The way we get rid of cosine is inverse cosine. So we're going to take the inverse cosine of all of that, and whatever you do on the left, you have to do on the right. Take the inverse cosine of all of that. I just put brackets on the left side because I already used parentheses as a grouping symbol for the argument. I could have just used a larger parenthesis, that's okay. But this is how I wrote it. Now, on the left, when you take the cosine, the inverse cosine of the cosine, it's like taking the square root of the square. They cancel each other out. And now, all you're left with is alpha. And I'm going to type in the inverse cosine of 6.1 over 12.7. So second inverse cosine, 6.1 divided by 12.7. And that gives me 61.294 degrees. Okay, I'm going to go put that up in my table. Now, if I was running out of time and I had to finish this problem in the next 10 seconds, I would do 90 minus 61.294 and pray that 61.294 was the correct answer. All right, so that means the other angle should be 28.706. But let's see if we can find beta the same way we found alpha. But keep that number in mind, 28.706. All right, so now let's look at finding beta and using those two sides. What you've just done is you switched your perspective. You're not at the same angle anymore. Now you're trying to find beta. That means that that side is no longer called adjacent. From beta, what is the 6.1 now?
Opposite.
Now it's opposite. C is still the hypotenuse. That doesn't change. But what trig function involves opposite and hypotenuse? Yep, sine. Okay, so let's find beta. And we're going to use the sine of our angle equals opposite over hypotenuse. Anytime you have a variable as the argument to a trig function, you're going to have to use inverse trig. It is the only way to get the variable by itself. Which inverse trig function do I need on this one? Yep.
Inverse sine.
Inverse sine. So we're going to take, write it that way this time, inverse sine of everything on the left. And I'm going to take the inverse sine of everything on the right. There is no multiplication happening with that inverse sine. That's the number I'm plugging into it. Okay? Just like if I wrote this, there's no multiplication there. That doesn't mean square root times 8. It means take the number 8 and fill it into the square root function. Okay? So take that fraction, fill it into the inverse sine function. All right, so on the left, those are gone. And let's see if we get 28.706. 6.1 divided by 12.7. And we get exactly the same answer. So because I got the same answer two different ways, now I'm pretty sure that it's right. All right. And that's how you solve a right triangle problem where I give you two sides. So that was that type. All right. Any question on the second type? All right. So first type, you never need inverse trig. Second type, you always need. And Pythagorean theorem from the second type. All right. I'm not going to do another one with two sides, but looking at the information that's given, are you going to be able to use Pythagorean theorem to find the third side here? What do we think? Yep.
Assuming it's a right triangle, yes.
Yeah, everything's a right triangle. So Pythagorean theorem is okay. Are you going to need inverse trig or no? Yes, you're going to have to use it. You're going to have to use it twice. Okay. All right. So let me draw a diagram and let's take a look at it. I'm going to put a point on that circle. And this should kind of look like unit circle trig. Right, that's the diagram. Let's call it a 45, 45, 90. When we did unit circle trig, what was the radius of the unit circle? Yep, 1. That side was a 1. We called the bottom side x, and we called the height y. And the whole goal of unit circle trig was to find the coordinate x, y. What I'm trying to do right now is show you the connection between unit circle trig and what you just learned. Okay, and I'm going to show you the exact same thing. When we did unit circle trig, what was the definition of sine? Sine was equal to yep.
Oh wait, sine was equal to, I think it was x.
Y, yep, perfect. How about the cosine? What was that equal to? Yeah.
X.
Cosine was x, nice. And what about the tangent? What was that? Yep.
Y over X.
Y over x. Okay. So when we learned unit circle trig, that's what we had. Now, what I want you to do is put an angle there and pretend that that's your reference point. Okay? Everything is going to be from the perspective of theta. Let's do the same thing again, but now instead of thinking about it as a unit circle, let's think about it as opposite, adjacent, and hypotenuse. The sine is opposite over hypotenuse. What's the opposite in that picture? Yep.
Y.
Y. And what's the hypotenuse?
1.
So y divided by 1 is what? Cosine is adjacent over hypotenuse. What's the adjacent in that picture? Yeah.
X.
And what's the hypotenuse?
1.
And x divided by 1 is x. What's the definition of tangent? Yeah.
Y divided by x.
Well, in terms of a right triangle.
That would be opposite over adjacent.
Opposite over adjacent. Opposite is y, adjacent is x. It's exactly the same thing. There's no difference. But now, let's extend this. And instead of saying that we have a circle of radius 1, let's say we have a circle of radius r. I want to look at what happens to my unit circle trig formulas. when the radius is r instead of 1. So now it's more generic. What do you think the formula for sine would be based on using what we just learned about right triangles in that diagram? Yep.
Y over R.
Y over r. How about the cosine? Yep.
X over R.
X over r. And the tangent? Yep. Still y over x. Those formulas that you just said are the 6 trig functions in terms of a circle of radius r. So now, instead of just thinking about it as radius 1, you can think about it as any radius. If you were to fill in a 1 for all those r's, you would get back the original formulas I taught you. Y, x, y over x, 1 over y, 1 over x, x over y. The tangent and cotangent are not affected by a larger circle. So now, sorry, I'm making it hard to read. I want to look at this problem. It says find the 6 trig functions of theta where the point 2, 3 is on the terminal side. Okay. So let's allow my writing disappeared. Oh. All right, let's sketch that. So I'm just going to draw a grid kind of by hand. I'll make the axes a different color so they stand out. All right. So it says find the 6 trig functions of an angle where 2, 3 is on the terminal side. It's x, it's y, 2, 3. 2, 3 is on the terminal side, means you have a side that's going right through that point. Where's your initial side? It's on the positive x-axis. We always assume the angle is standard position. So that is what I'm having you measure. You're looking at that angle right there. Okay. In order to do right triangle trig, what shape do we have to create out of that? Yeah.
Right triangle.
Yeah, we need to make a right triangle. So let's think of it just like you would if that point was on a circle, just like this. You're basically doing unit circle trig, but now the size of the circle isn't 1. It's bigger than 1. So we know the x, and we know the y. X is 2, y is 3. What we don't know is the size of that circle. How could I figure out the size of my circle that I'm working with? The size of the circle is really something else in that picture. It's the what? Yep.
I was going to say you can use Pythagorean theorem.
Yeah, because it's the hypotenuse of that blue triangle. So what's going to be the radius of my circle based on using the Pythagorean theorem with a 2 and a 3? Yeah.
It's going to be the root of 15 because 2 squared plus 3 squared equals 15.
2 squared plus 3 squared equals 15.
Yeah, 4 plus 9.
4 plus 9?
No, 13. My bad.
13, okay. So the radius is going to be the square root of 13. Now, you've got your x, you've got your y, you've got your r. Just fill up into all those formulas, and you'll get all 6 trig functions. We'll leave that there. Okay, so my sine is y over r. So 3 root 13 over 13. My cosine is x over r. So 2 root 13 over 13. My tangent is y over x. So 3 over 2. My cotangent is 2 over 3. My cosecant is going to be root 13 over 3. And my secant is root 13 over 2. So thinking of it that way, we just did basically what we did with unit circle trig, except we didn't do it on a circle of radius 1. We did it on a circle of radius square root 13. But it's still the same idea. Any question on that? Right, so now, how big is the angle? Any one of these is enough information to figure out the size of that angle. Let's take this one. The sine of theta equals 3 root 13 over 13. How would I get theta by itself in that equation so I could get the size of that angle? Yeah?
Did you take the inverse of sine?
Yeah, we're going to take the inverse sine on both sides. That's exactly what we just did. And do you have to do it with inverse sine? No, you could use one of these other ones, but I would recommend sticking with that. So the inverse sine of 3 square root of 13 divided by 13 gives me an angle of 56 point, we'll call it 31 because it rounds up, 56.31 degrees. And there's your angle. Any question on how I figured out the size of the angle from example 3? All right, so I knew that that angle had to come out between 0 and 90. The reason I knew that is because it's in quadrant 1. It is possible we get angles in other quadrants, but in this problem, that didn't happen. But if we end up with an angle that's in a different quadrant, just using inverse sine might not give you the right answer. Okay? Like if you've got an angle down like that, you're trying to find that angle. It's not going to give you the right answer because you're not in the first quadrant. So we're going to have to adjust the answer that we get. And this is how we do it. So when we did some graphing the other day, and you would do second calc intersect, and you would find where a trig function was crossing a straight line. A lot of times I would say this isn't the fastest way to do it. There's a way to figure out the other answer without graphing. That's what this is getting at. All right. So whenever we want to find an angle in another quadrant, we start with what's called the reference angle. This in green right here, that's my reference angle. If I draw it for every quadrant, make a triangle for you in every quadrant. The reference angle is what I'm marking in red right there. It's the angle between the hypotenuse and the x-axis. If you are in quadrant 1, then the reference angle is automatically the angle you want. If you are in quadrant 2, the angle that you would want is that. How would you figure that out? Well, if you knew that part right there, and you take 180 and you subtract that, like let's say that was 20. If that's 20, then this part has to be 160. So if you are in quadrant 2, you take 180 and you subtract that. If you want to find an angle in quadrant 3, that would be like that. When you do the inverse sine, it's going to give you your reference angle. That's just that piece right there. If you add that to 180, you'll get the angle in quadrant 3. And in quadrant 4, that's your reference angle. If you subtract that from 360, that will give you that piece right there. Because 360 would be all the way around, but you're not going all the way around, you're that much short of going all the way around. So if you subtract that from 360, you'll get the amount that you did go around. So let's apply that to this problem. It's still a 2 and a negative 3. So it's technically going to still kind of be the same reference angle. That 57 point whatever we got, or 56.31. It's just now in a different quadrant. Okay. So first thing is you have to know what quadrant that point is. It's right 2, down 3. Which quadrant is 2, negative 3 in?
Fourth quadrant.
In the 4th quadrant. So we're going to find our reference angle by using the inverse sine. Because it's a reference angle, it has to be positive. Okay, reference angles are always positive. So let's do the inverse sine. Or, you know what, if you want to, I'll show you how you can set it up. There's your triangle. Right 2, down 3. What you are solving for is that. You're going to find that angle right there. And then the answer that I want is that. Okay. So this side is 2. This side is 3. That's going to be my reference angle. All right. What side am I missing there to do that? Yeah.
Missing the hypotenuse.
I'm missing the hypotenuse, but we already found it before. It was the square root of 13. So that's the first thing I do. If I'm missing any sides in my triangle, I figure them out using Pythagorean theorem. Now, let's set it up using sine. Sine of theta equals opposite, which is 3. I mean, technically it is a negative 3, but the absolute value is going to take care of that. So opposite over hypotenuse. We're going to type that in on the calculator. Inverse sine of negative 3 divided by square root of 13. It's the same angle we had before, 56. Remember, make it positive because it's a reference angle. What do I do with that angle to find the answer for that part in blue? Yeah?
You subtract the reference angle from 360 because it's in quadrant 4.
Right. We're going to subtract that reference angle from 360. So 56 point, I'm just going to call it 56.31. That means that angle in blue is 303.69. And that's how you find how big an angle is in another quadrant. Find your reference angle, and then either subtract it from 180, add it to 180, or subtract it from 360. If you're in quadrant 1, you don't need to do any of that. Your inverse sine is your answer, and you're done. But in 2, 3, and 4, you need to adjust it. All right. Any question on that? Okay. So the very last thing we're not going to get to, I'm just going to put that up, and that'll be the last thing. The angles 0, 90, 180, and 270. Those, I think I said this before, those are called quadrantal angles. Okay, those are your quadrantal angles, and when we did unit circle trig with them, all our answers were either 1s, -1s, 0s, or undefined. Okay, so I'm not going to have time to put the test topics up right now, but I will put those on the board after you guys leave, and then I'll post it on YouTube, and I'll be after school today for extra help.